Alright, okay, hello, my name is Ashraf, so I'm going to teach you guys on the chemistry for SPM. Alright, okay, so this is the question that I choose. We're going to use the lesson that we learned just now. Okay, now look at the question. Diagram shows the chemical changes occur in carbonate P. Okay, but this one is easy, only mentioned already to you that carbonate P meaning carbonate salt. Okay, when solid P is heated strongly, it decomposes to form a solid R. Okay, to form a solid R and release gas S. Okay, now look at the flow. Okay, so this one solid P goes into this is a heated okay, heated to produce a solid R and also gas S. Okay, if you can see here, gas S, you react with the you flow the gases into a lime water here. It gonna turns into a cloudy. Okay, the lime water gonna turns cloudy. So what does this mean? Okay, meaning that your gas S is your CO2. Okay, alright, now look at the other side of the flow chart. Okay, solid P produce a colorless solution Q. Okay, you dilute this one, meaning you dilute inside a water, okay, to form a solution. Okay, colorless solution Q. Alright, you react the colorless solution Q with an AOH. Okay, remember the cation test, there is two solutions that we're going to use. The first one is an AOH and the second one is the ammonia solution. Okay, so the first one, white precipitate dissolve in excess and AOH. Okay, white precipitate dissolve in a excess and AOH. Okay, if you still remember, we have two possibilities, right? Dissolve and not dissolve. Okay. Okay. So when you have a dissolve in excess, so meaning here might contain lead, aluminate, and also zinc. Alright. Okay. And then you use the same sample, meaning the new sample lah. Okay. When you done already this one, you're gonna use a new to test with the ammonia solution. Okay, in excess, white precipitate also dissolve in excess and H3. Okay, there is only one possibility when it dissolve in NH3, which is zinc ion. Okay, Zn2 plus. Okay, because just now it's already mentioned to you that it is a carbonate P. Okay, carbonate salt. So when carbonate salt, you have your zinc as the cation, so we know already our solid P is a zinc carbonate. Okay, alright. Okay, now look at the solid R. Solid R, when you heat out a carbonate salt, you will produce carbon dioxide gas and also metal oxide. Okay, so now we know already our metal here is zinc, so your solid R is zinc oxide. Okay, and the colorless solution, okay, colorless solution Q is Zn as zinc sulfate, because you dilute this one into a, I believe this one is H2SO4. There should be acid there first. Okay. Okay. Now why this one dilute into a acid H2SO4? Because you look here, solid P is zinc carbonate. Carbonate salt is one of the insoluble salt. Correct now? Okay, so when this one is insoluble salt, you cannot use water. I'm sorry, just now I said you use water, right? Okay, you cannot use water. You need to use acid, okay, to dilute, to make it into a solution first. Because before you do a cation test or any test, you need to use a solution. Okay, so instead of using water, we're gonna use a acid to dilute. So we are using H2SO4. Okay, so zinc ion inside your solid P are going to react with the acid to produce a zinc sulfate. Okay, so zinc sulfate is a soluble salt. That's why you can see a colorless solution of Q. Okay, alright, next one. Okay, question 2. Okay, diagram 11 shows a series of reactions for salt A. Alright, white solid A, reaction 1 plus with the nitric acid. Okay, Remember I said just now, sometimes when the salt is insoluble, you need to use an acid. Okay, why? Because you want to form a solution. Okay, so white solid A are going to react with HNO3 to form a colorless solution B, which is in here, right here. Okay, your cation already reacted with the nitrate. Okay, are already reacted with the nitrate. Okay, so look at our most important point here. Okay, the first one here, the reaction 2 here. Okay, reaction 2, you react your colorless solution with the potassium iodide. Remember the confirmatory test of the cation to determine 2 types of cation, which is your lead and also your aluminium. Okay, so when you react with your colorless solution just now, you react with the potassium iodide, form a yellow precipitate. This one we know already, contain Pb2 plus ion. Okay, alright. And then you see here on the excess, using excess of NaOH, it form a colorless solution. Colorless meaning dissolve. Okay, and then when you use excess of ammonia solution, it produce a white precipitate. White precipitate meaning not dissolve. Okay, alright. So now, what is solid A? Okay, when you do a reaction with acid, when you use a solid metal carbonate with the acid, it will form 3 things, which is salt, colorless gas, which is your carbon dioxide, and also water. Okay, so from here, we can indicate that here is your CO2 and here is your H2O. Okay, because metal carbonate reacted with acid here. Okay, to produce 3 things. Okay, salt, colorless gas, and also water, which is your CO2. Okay, solid A is, because we know just now we have our Pb2 plus. Okay, so white solid A is a CO2. Okay, and the colorless solution B, because you react lead salt with the nitrate acid. Okay, your nitrate ion will react with the Pb2 plus ion to produce a PbNO3. Okay, alright, and the colorless gas just now is, as I mentioned just now, metal carbonate react with the acid, we produce a colorless gas. Okay, and then the yellow precipitate that we have, as I mentioned just now on our earlier lesson, the confirmatory test, it will produce a lead 2 iodide. Okay, PbI2. Okay, right, now move on to the question for Form 5. Okay, as I mentioned just now on the analysis part, chapter 1 is the most famous chapter that are going to be asked in your exam. Okay, I'm going to choose chemical cell, okay, for our example. Okay, now look at the difference between voltaic cell and also electrolytic cell. Okay, the structure of the cell, where voltaic cell, there is no dry cell, there is no battery, but for the electrolytic cell, there will be a source of energy. Okay, battery lah. Okay, energy change for a voltaic cell, it is a chemical to an electrical. For the electrolytic cell, it is electrical to a chemical. Okay, electric current and reaction, chemical reaction produce an electric current, and this for electrolytic, electric current result in a chemical reaction. You are going to use the electric. Okay, so for the cathode and anode, cathode for the voltaic cell are going to be a positive terminal and anode will be a negative terminal. So this one, there is one method how to memorize. Okay, for a voltaic cell, VAN. Okay, which your V is stand for a voltaic, A is stand for anode, and N is for the negative. Okay, but for the electrolytic is EAT. Okay, E is for electrolytic cell, A is for the anode, T is symbolize the positive sign. Okay, so we know the anode for the electrolytic cell is on the positive terminal. Okay, flow of the electron is same for the both. It always from anode to the cathode. Okay, so what happened to the what will happen to the negative terminal? For voltaic cell, electron will be released. For electrolytic cell, electrons are received. Okay. For the positive terminal, voltaic cell, electrons are received, and for the electrolytic cell, electrons. This question, I encountered this one 2 times in a trial, previous trial. This question, okay. We're gonna see on how to get 5 marks from this question. Okay. Diagram shows the apparatus setup of purification process of copper metal, but if you see from this setup, there is no battery. Okay, there is no battery, but you can see on cell Q, both are using copper as the electrode. Okay, for cell P, we are using zinc and copper, different metal, as our electrode. Okay, now look at here first. Okay, I'm telling that cell P is a voltaic cell and cell Q is electrolytic cell. Okay, you might be asked, teacher, how you know that cell Q is electrolytic cell? How you know that cell P is a voltaic cell? Okay, for electrolytic cell, both of the electrode, they are using a same types of metal. Okay, so you can see here, both cathode and anode, they are using a copper. Okay, for a voltaic cell, okay, for voltaic cell, they are using a different types of metal. Because why? Because they want to have the potential difference. Okay, so that the electron can flow. All right. Now look at this side. Okay. Zinc and copper. How I want to know which one is cathode, which one is anode? Okay. So there is one thing that I memorized, but this one in Malay lah. Okay. So it's actually start with hold on. Okay. K N A C M G A L Z N F E S N P B H C U A G and A U. Okay, so how I memorize this one? Okay, kalau nak cantik, minum air zam-zam, fuyo, sedap. P is for pasti, H is for hebat, cuma ambil is for ambil air. Okay, kalau nak cantik, minum air zam-zam, fuyo, sedap, pasti, hebat, cuma ambil air. Okay, this one is electrochemical series. Okay, so electrochemical series are telling you that, okay, the more higher your position, or the more higher the element position, the more easy for the element to donate the electron, meaning the tendency to become electropositive is higher. Okay, so now we have zinc and we have copper. If we look at the position, okay, if you look at the position of zinc here and also copper here, you will see that zinc is more higher the position compared to the copper. So zinc is a higher tendency to become electropositive or donating the electron. Okay, so the movement of the electron, as I mentioned just now, okay, we start from the zinc. Okay, we'll start from the zinc. So the electron will move from the anode of the voltaic cell to the other side of your so this one is our electrolytic cell. Okay, so now when this electrode are attached to this one is your anode, right? Anode is the negative terminal. Okay, so this one is the negative terminal. Okay, negative, when your electrode are attached to the negative terminal, negative will attracting a positive. Okay, this one are attached to the negative terminal, negative will attract a positive. Positive what? Positive ion. Okay, so this one is your electrolytic cell. Electrolytic that attached to the negative is EAT. Okay, your anode is your positive terminal, meaning that your cathode is your negative terminal. So this one is your cathode. Okay, so this is the cathode. Okay, cathode are attracting a cation. Alright, so we are using a copper to sulfate solution. So inside your solution contain so inside your solution contain Cu2 plus and also SO4 2 minus. Okay, because this one is solution, actually you got two more things, H plus and also OH minus. Alright, so all of the positive ion will move toward the cathode, and all of the negative ion will move to the anode. So this is your cathode, so this one will be your anode. Okay, as I mentioned just now, the movement of electron will always from anode to the cathode. Okay, so your electron will continue the movement from the anode of your electrolytic cell. Okay, alright. Okay, the question is asked for, based on the diagram, compare the observation on the color of electrolyte in cell P and cell Q after 30 minutes. Okay, and then you need to explain your answer. Okay, for this one, cell P, inside here also you got the same thing, which is Cu2 plus, SO4 2 minus, H plus and also OH minus. Okay, so inside here you will have these four ions. Okay, and we know that the movement of the electron will start from the anode. Okay, so zinc will donate, so this one will donate electron. The electron is coming from the OH minus. Okay, so this one will donate the electron. So electron will move towards this external circuit and go into the cathode. Okay, so what happened to the cathode? As I mentioned, it's going to attract a positive ion. So all the positive ion are going to move to the cathode. But which ion will be discharged? Okay, remember one thing, the reason why the ion move toward the electrode is for one reason only, which is they want to be discharged. What is discharged? Remove the charges. Okay, they want to remove the charges. Alright, so here, between H plus and Cu2 plus, okay, Cu will be chosen. Okay, Cu will be chosen to discharge to become a Cu atom. Okay, but then, okay, between H and Cu, Cu is less electropositive, so that's why Cu will receive or gain the electron compared to the hydrogen. Okay, so here we need to balance the equation. You will have 2E plus Cu2 plus produce Cu as a solid. Okay, so when you see the formation of the solid here, we can see, okay, we can see that this size of the electrode are going to become bigger. Okay, the size of your electrode are going to become bigger. Why? Because all the Cu2 plus just now in a solution are going to be changed or are going to be discharged to form a copper atom. Okay, so copper atom is a solid, okay, solid metal. So you can see the brown metal is being deposited at the cathode. Okay, the size of the cathode are going to increase. Alright, so what will happen to this anode? Okay, so at the anode side, okay, at the anode side we are using copper. Okay, we are using copper. So the one that going to donate the ion instead of OH minus just now, it's going to be our copper metal. Okay, so copper metal are going to discharge. This one is for cathode, this one is for the anode. Okay, so copper metal we're going to ionize, are going to be ionized to form a Cu2 plus ion. Okay, where does this Cu2 plus ion go? It's going to dilute or going to dissolve into the solution again. Okay, so right, so you can see that when the solid are changed into the ion, okay, from a solid just now, from a solid metal just now, the Cu atom inside the metal are going to ionize to form Cu2 plus, going to go into the solution. So what will happen to the what is the observation that you can see from the anode side is that the copper metal are going to become thinner or become smaller, or the weight are going to reduce. Okay, so this side are going to become smaller. Okay, the reason it becomes smaller because just now as I mentioned, Cu are going to become Cu2 plus. Okay, so now the electron are going to move from anode of your electrolytic cell, and then move into the cathode of the voltaic cell here, and the electron just now are going to go and find the positive ion in this voltaic cell, okay, which is what? Cu2 plus lah. Okay, so Cu2 plus in copper 2 sulfate solution on the voltaic cell are going to receive the electron to form a solid. Okay, so this one we having the half equation for electrolytic. Okay, for the voltaic cell, okay, cathode, as I mentioned just now, Cu2 plus are going to receive 2 of the electron to form a Cu solid. Okay, going to form Cu solid. Okay, so you can see here that the formation of solid will be formed at the cathode. Okay, sorry, at the anode side, sorry. Okay, alright, so if you see here, you can see the formation of copper metal here. Okay, so when this side of your electrode are receiving the electron, it will become bigger. Okay, it's coming from a Cu here. Okay, it's coming from the Cu there. Alright. Okay, so at the anode side, it's actually OH minus are going to discharge to form a oxygen gas and also water. Okay, balance it. Okay, alright. So now the question are asked for the compare the observation on the color of your electrolyte color. Okay, as we know that copper 2 sulfate is in blue color solution. Okay, blue color solution because of presence of Cu2 plus. Okay, look at the cell P here. Okay, concentration of Cu2 plus are going to become lesser and lesser. Because why? Because Cu2 plus just now are going to become Cu, are going to discharge to become Cu. Okay, meaning in this solution, the concentration is lesser, lesser and lesser. When the concentration of Cu2 plus is lesser, lesser and lesser, meaning that because we know that the blue color is coming from the Cu2 plus. So when the concentration is lesser and lesser, the intensity of the blue color solution are also going to reduce. Okay, there is some space. Okay, I'm going to clear this first. I'm going to write it again. Okay, compare the observation. Okay, on the cell P, blue color solution will become pale, or you can say intensity of blue color solution reduced. Okay, alright, the reason reduced is because concentration of Cu2 plus decreased. Why decrease? Okay, why decrease? Because Cu2 plus in the solution being discharged to form Cu metal. Okay, alright. This is what happened on the voltaic cell. Okay. On the electrolytic cell, okay, you're going to explain the same thing also on in terms of the color of the blue solution. Okay. Blue color solution in cell Q will remain. Why remain? Because just now, okay, as I mentioned to you that Cu will ionize to form Cu2 plus, okay, and then for the negative terminal, the electron at the negative terminal are going to give the electron to the Cu2 plus, and then the Cu2 plus will become a copper metal. Okay, why the remains? Because the rate of ionizing of Cu metal is equal to the rate of discharge of Cu2 plus. Okay, so concentration of Cu2 plus in the solution is remains. Okay, so that's why we can see color of the blue solution is remain. Alright, so you can also include the half equation that I mentioned just now in your explanation, but then this one is 5 marks only, but this one can go up to 6 or 7 marks, so you can include the half equation that I introduced to you guys just now. Okay. Alright, so that's all from me. I wish you guys the best for your coming SPM for batch 2023, and see you guys soon. Bye.